the team and I are at the Collaborative Engineering Center, or CEC, here at NASA Marshall. The CEC is a facility that enables scientists and engineers from across the country to study spacecraft architecture in a virtual environment, kind of like a chat room, before they build the vehicles. They do this by using computer simulations. Kathy, if I remember correctly, a computer simulation is a powerful tool that allows engineers such as yourself to input data into a program.
Exactly. We get to play, or I mean study, what-ifs with different types of engines, structures, thermal protection, and whatever we want to test just by changing the data.
That's great. Now, what do you have the kids working on today?
Earlier, we talked about how different fuel choices, which propel the spacecraft, affect the launch weight of the vehicle. By using computer simulations, we can get a real-time idea of how these choices affect the whole architecture. The computer simulation shows how one change can ripple through the entire system, like waves on a pond.
I get it. Computer simulations allow designers to see how one choice can affect the big picture.
Yes, and another reason why simulations are so useful is because we have over 20 years of experience with the space shuttle.
I see. So by looking at similar numbers and costs from the shuttle program, you have a starting off point to begin testing new ideas.
Well, yes, sometimes, of course, we have to use, engineers have to use their estimating skills to come up with a starting point for their calculations.
Oh, well, can you give me an example?
Sure. Suppose you are looking at TPS, thermal protection systems. Let's say that a low-maintenance TPS system weighs 3,000 kilograms, and the total weight of the vehicle is 75,000 kilograms. How would you estimate the thermal protection system weight to the vehicle weight ratio?
Okay, let's see. 3,000 kilograms TPS weight to 75,000 kilograms of vehicle weight. If I simplify and reduce, it's about 1 to 25.
Exactly. We might find that one system is heavier, but the reduced maintenance costs might still make it a good idea. Of course, eventually you have to build and test systems and hardware, but think of the time and money you save testing with the simulations first.
And it allows more creativity.
Absolutely. See how they're trying different thermal protection systems? Look what it does to the vehicle weight and structure too.
What did we do before we had all this technology?
Well, for one thing, we did calculations by hand. We also built and tested a whole lot more hardware. Of course, that was okay then, but now engineers have so many more tools to help them. But they still must use math, science, and technology. First, there has to be computer scientists and mathematicians to design the software and hardware that is needed for computer simulations. Remember, the computer only calculates the data, but the engineers need sharp math and science skills to analyze the results and decide on the final design. The Space Launch Initiative will get a spacecraft to orbit more safely and less expensively. That's going to take a team effort, and it's not too early for your next generation explorers to start getting ready. Doing well in school is the most important step.